Hello everyone, today we are here for Lab 4 circuits. The purpose of this lab is to apply the principles of energy conservation and current conservation to predict the behavior of circuits. We can use a loop rule and Kirchhoff's law. Basically, we will use two experiments in which we'll make two circuits, and then based on the lab for instruction PDF, we'll take different readings using ammeter and voltmeter. The laws involved are Kirchhoff's rule that states that the sum of currents entering any point in a circuit must be equal to the sum of currents leaving that point. The loop rule states that the sum of the potential differences around any closed loop in a circuit must be zero. This is the experiment one. You can pause it and look at the 8 points on how to make it. But this is basically it. You see that the current is 0.02 ampere, and then the voltage across the resistor, the 47 ohm resistor, which is this one, is 0.95 ampere, while for the other one, which is the 100 ohm resistor, it's 0.25 sorry 2.05 volt, and then using the loop rule, you get it's zero, so there's conservation of energy. This is the graph, so you can see when it when current enters the 47 ohm resistor, the voltage decreases a bit, and then it stoops up because wires in this experiment have no uh, resistance, but in reality they do have some resistance. And then when the current passes to the 100 ohm resistor, it again goes down, again obeying the loop rule. In experiment two, basically this was supposed to be a 1 Faraday capacitor, but I could not find a 1 Faraday, so I used five uh, 0.2 Faraday capacitors and added them in parallel. We basically see that for the 10 and 20 ohm bulb, the current decreases. It decreases faster for the 20 ohm bulb. On an average, it takes around 15 seconds for the 10 ohm bulb to exhaust, while it only takes like 4 seconds for the 20 ohm bulb to exhaust. And then for the battery, again, it recharges the battery. And when the capacitors are charged to their maximum, the current stops flowing. But in reality, the current still keeps flowing till infinity. And then this is the RC circuit. So the log delta V by V, it's a line with a negative slope. There couldn't be any errors because this was a computer simulation. There could have been errors in graphing because that was done by hand. The what if question asks that in reality, would the actual ammeter show a different reading if used instead of the ideal simulated ammeter? Yeah, the readings in the ammeter would change and most likely decrease, as in real life both ammeter and the wires on the circuits have some resistance. And the second one asks that you are doing this lab experiment in real life and use a real battery to charge the capacitor. And in reality, it would still take more time for the capacitors to charge because again the wires have some resistance, and in reality, it takes to infinity to charge a capacitor. Thank you and have a nice day.